I want to increase to 4 micron or 8 micron so that required properties can be achieved. That is generally for aircraft aluminum alloy, we do this anodization process. Without that, we will not apply, use that part or the structure or anything. Pure aluminum, it may give you the required strength, lightweight, everything. But it has a very good, it has a lacuna about corrosion resistance, particularly galvanic corrosion resistance. So for that, definitely anodization is the treatment. It is required. Without that, that part cannot be assembled with the aircraft. In the case of molten laser technique is there. Otherwise, thermal spraying techniques are available like plasma spray technique. Tomorrow, I think speaker will talk about thermal spray process. That is HUIF, that is high velocity RCPL, cold spray coating, atmospheric plasma spray. These are all the methods available. So variety of these coating methods can be used to improve the properties of the either steel or aluminum or which doesn't possess that property.
So is it possible to coat the material nanomaterial, especially and chemical reduction process?
Yes, it is possible. Yeah. That's all what I say, chemical reduction, you may get either to do nail and this one. It has 4 properties in the sense, for example, it is completely covered with copper. If I touch, rub it, it will come off. So unless otherwise, to make it more adherent, I need to have a cleaning process. Pre-treatment we call it as. I will talk about it.
What about the electrode material? Should be like this or should be any method?
Yeah, anything you can take it. That is the advantage with the electrolysis process. You can deposit on steel or the nickel based or super alloy, you can deposit titanium, you can deposit. Either it is possible to deposit on wood or for biological application, somebody wants to see. I want to see high magnification scanning electron microscopy, how this particular surface appears. There I can't do any other coating other than this particular coating you can use. There are room temperature coating, you use that conductive, that surface, so that high magnification you can look at it, what exactly the features, all those things you can see.
Yeah. Salt gel process used for carbon nanotube production.
No. Salt gel process not for carbon nanotube, it is some other process. It is not salt gel process in the sense again, it is a ceramic coating only. It is a salt organic material, both are there. Okay, so it will precipitate and finally it will form like a salt gel coating. Particularly, for example, you might have seen these windows, door knobs, all those things. Continuously you are using that one. There is a tarnishing or sometimes coating also may goes on. For example, hot chrome, a thin hot chrome coating plating is given. Because of the environment, what will happen? It may corrode or it may lose that decorative appearance. What they do after this coating is done, for example, hot chrome coating or a decorative chrome coating, that it is dipped in this salt gel formulation. So that will give you a thin coating of oxide layer. For example, silicon oxide actually. SiO2. You have variety of things you can do. Which containing cerium, which containing anything you can dope it, so that it will give, apart from tarnishing, anti-tarnishing you can give, it also gives you the good wear resistance, corrosion resistance, all those. Each has its own advantages and disadvantages. Okay? That if you research something different, I am not going to talk about it. Okay? Let me go to electrolysis plated coatings for surface engineering. As I told you, it is a simple, versatile and cost effective. For example, it is a very complex shape is there. By electrode deposition, what will happen? It is depends on the current density lines. Because of that, probably I may end up, I want to 25 microns toward the uniform thickness of this part. What will I end up? I may get some 100 microns here because current density lines are much higher compared to this portion center. So there is a non-uniformity there. So what I should do, even though I want 25 micron, but here it will be 5 micron, definitely I have to increase the duration. Instead of 15 minutes, I have to coat it for 1 hour. After that, I have to, another mechanical operation is required to remove the excess material. Here it is not like that. It is a simple chemical reduction process in which it has the metal source will be there. Apart from that, you have a reducing agent, and together with some complex agent, buffering agents, all these ingredients which are properly maintaining the pH and particular temperature, you will get uniform coating because here there is no electrode is there. Simple, ensure that this component is completely thoroughly cleaned, degreased. Whenever you talk from machine shop, it comes out in a, because the oil will be there, some lubricant will be there, grease will be there. As such, if you do that, because coating, no coating will form for that. That means pre-treatment plays an important role. Okay. So once it is properly treated, what will be the shape of the component? Exactly, it takes the contour and it is possible to play. That is the one advantage. Process methodology is easily tailored to meet the required. For example, I want to have optical property. Accordingly, I can choose the coating. For example, I am going to give you the example like high reflectivity, which we have worked for a metallic mirror. We have developed for insert two series of satellites. Okay, that I will give you much more details. There, high reflectance is required for that metallic mirror. Ensure that whatever the sunlight falls on that mirror entirely, it should be reflected back. 99% should be reflected back. So that whatever the detector kept inside that, always it should be maintained at 105 vehicle. That is the one big advantage. For example, I want to have very hard coating. What I will always prefer electrolytical coating with the silicon carbide particle, tungsten carbide particle, or you can choose this molten disulfide like the lubricant particle, hexagonal boron nitride particle. Variety of these particles can be co-deposited and you can use it for variations application. For example, I want to have a coating which should give you the very good corrosion resistance. So I can tailor in such a way that my coating will have good passivity. Passive layer should form so that the passive layer will give you the required corrosion protection. Like according to my requirement, I can tailor. That is the advantage. Alloying of phosphorus. Whenever I talk about electrolytical, in generic term, it is not pure nickel. Okay. So along with that, depending on the reducing agent I am using, either phosphorus or boron will be co-deposited, or phosphorus boron both. Someone can ask me, is it possible to deposit by this electrolysis method pure nickel also? Yes, it is possible. That is because whenever you talk hydrogen kind of reducing agent is available. When I use that, you will get the pure nickel, but efficiency of the quartz will be very, very less. Unless otherwise, definitely I need for my application thin metallization. For example, nanometer level or 1 or 2 nanometer level, I need thickness. That time definitely I choose it. I will select that particular coating. So then offers the possibility to prepare duplex graded. So for example, I want to have very high hardness. Further slides I am going to give an example also. I want to have hardness, nickel boron. Generally, these coatings will give very high hardness equivalent to your hard chrome. Hard chrome, if you look at it, hardness is 900 to 1000 vickers. Am I correct? So these NIB deposits, that means boron content will be around 3-8% or 5-8%. When I deposit along with co-deposit with nickel, after heat treatment 400 degrees for 1 hour, hardness will be more than 900 or 1000 vickers. Okay, accordingly. So I have the duplex. For example, I want the top hard coat, bottom, after some time, corrosive environment is there. Even there are some pinholes or pores are present. Bottom I have thickness of maybe 20 microns. I have given high phosphorus coating, so that as a duplex coating it will give you the both purposes by protecting the substrate, maybe mildly like that. Graded coatings. For example, here also I will modify the bath in such a way that while addition of the reducing agent, slowly I will increase. In the sense, initially it will be low concentration, like that. Periodically I will add it so that what are the co-deposited either phosphorus or boron from surface to the, interface to the surface, there will be a variation in the concentration of co-deposited phosphorus or boron. That way also it has other advantages. Like that, variety of coatings can be deposited by this particular method. So you can ask me what are the methods I can do the electrolysis plating. What are the methods? Nickel, it is widely used in the industry. Most of the industries like automobile, aerospace, or electronic application, this is widely used. Copper, again PCB, electronic application, particularly PCB application, it is used. Gold, again microelectronic application. Silver also similarly, palladium, cobalt, rhenium. These are all the metals that can be deposited by by this electrolysis plating method. You can ask me, sir, is it not possible? Chromium, hard chromium, it is by electrodeposition. Is it not possible here? No, it is not possible because